Hi, my name is Gavin Ruane, and I'm a student in CPE 233, Section 7, and this is my Lab 7 programming assignment demonstration video. For this assignment, students were, like last week, tasked with creating a program for their Basis 3 boards and the RISC-V microcontrollers that they have modeled. And with this program, students were tasked with first causing the rightmost display to blink a 0, and second, when the left button is initiated, for this rightmost display to count up to 9 at half of a clock cycle, and then return back to 0. So this is similar to last week in that it has some similar parameters that, which I've written down here again as my conditions, that while we're waiting, it's just going to continuously blink 0 on the rightmost display. We're going to wait for a button press to do anything, and we're not going to do anything unless the button is released. If the button is still held down, we're not going to let it keep going. And also, it's important that we want it to go back to the state, and we want it to do it as many times as possible. We don't want it to just do it one time. But that's pretty much it for the conditions. So as I said, I've written them down here. We're going to go through each of these tests or conditions. And we're going to make sure that this program that I wrote for this board is working properly. So let's get started. So as you can see, we're already passing the first condition. The rightmost display is blinking 0 while we're waiting because we're not doing anything. We're in the waiting state right now. So we're going to mark that one as done. Now let's actually test out the counting portion. So the left button press should initiate a counting up to 9. So I'm going to do that right now. And, oh, there we go. We're counting up to 9. And as you see, once we get to 9, we go back to 0 and we start blinking again. And that's exactly the behavior we want. We don't want it to get stuck. We don't want it to stay there and wait for another button press. No, we want it to go back to 0 and wait for another button press. And you may have noticed, I'm going to do it again, but the blinking of, the updating of the 7-segment display while we're counting is much faster. It's half of the clock speed than this blinking. So we're also passing that as well because we just want that to be faster for this program. Okay, and then, oh, we already said this. We already returned back to blinking 0. We've seen that. So we're going to check that one off. Now let's test this last one, checks for button release. So I'm going to hold down the button this time. I'm not going to just press it like I did before to demonstrate that when I hold it down, it's going to wait for me to release it to do anything, okay? So holding it down, it's going to do its thing. It's going to count up as usual. But once we get here and I'm still holding it down, it's going to stay at 9. It's not going to keep going. It's not going to do another count. It's not going to do anything until I let go. When I let go, we're going to go back to 0 and start blinking. Now, before I fix this, it would keep going through in a loop. It would keep counting 1 through 9, 1 through 9, but this is not the behavior we want. We want this to only assert when I have pressed the leftmost button. So we're passing that condition as well. And that's pretty much it for this assignment. I'll do it one more time just to show you how it works, but that's pretty much it. Thanks for watching, and stay tuned for the next one.